Dynamic allocation. Managing memory on disk. In previous videos dealing with databases, we went so far as to allocate fixed blocks of equal size. These blocks being relatively large, say 64K. The simplest way to get started is with what I call incidental allocation. Take our file layout. Incidental allocation takes place inside of a 64K block. This block is allocated specifically for this purpose. When a need arises for a block of memory that's less than 64K, it can be placed in the incidental block. The incidental memory pattern doesn't support deleting and reclaiming this data. It is a grow-only memory pattern. A pattern that supports deletes we'll talk about later. Another memory pattern that frequently arises is growth. Inside of our incidental memory buffer, it may be advantageous for us to append to a data block. One method of dealing with this is the list method, where the beginning or end of each block has a header or a footer that indicates when the next block begins, if there is a next block. The list method works fairly well for sequential access of the data. Another pattern uses a universal header. This is the index method. The index keeps track of all the blocks, where they reside, how big they are, in one location. This is better for random access. Packing and alignment. When implementing an incidental allocation as described earlier, I usually don't implement reallocation or freeing of the data. Also, the one-byte alignment can cause trouble when writing an algorithm that keeps track of all of these miscellaneous blocks. What it does have going for it is it's simple and optimally packs the data, meaning that exactly the amount you allocate is exactly the amount used. To move past the fundamental limitations of incidental allocation, we need to use allocation size ranking. This gives us the most flexibility to be able to allocate blocks and fit them. With this much more orderly design, developing an algorithm to find gaps and fill them is much easier. This comes at the cost of capacity. Every allocation won't fit precisely in the block that it's assigned to.